recording, so I hope you guys are with me. Formula sheet, super helpful if you have it close. Okay, what I said was going to either make you love or hate this is your algebra skill. Okay, so if you can rearrange formulas and you can see things in different formats, I think you'll find that this feels a little bit more comfortable. Some of you may say that this is never going to feel comfortable. If you plan on taking calc in university, you will have to know your sum and difference, your double angles, all these identities will be in there. They did half identities as well, but we don't do that in grade 12, which is sad. Okay, here we go. So there will be times where I give you an angle and I want an exact value, but it's not an angle on the unit circle. But if you took two angles from the unit circle, you could either add or subtract them and get that angle, then you can use the sum or difference identities. So that's what these are. Okay, let's talk about multiplying. Does it matter what order I multiply in? No. So could this be listed as cos beta times sine alpha? Yeah. Okay, so just know if you see it in a different format, depending on who's doing it or textbook or where I pulled it from, it just might be in a different order, which isn't the end of the world. Now you can't switch when they are like this term versus this term. You can't change their location. All right, so that's what we use our sum and difference formulas, and they are here and here. So 6.2, 6.2, and that one was 6.1. And that was way back in like chapter 4. I'm going to say, I think it was 4.2. All right. Oh, look, I added an extra e to formula. That's cool. Just get rid of that. Okay, so I want you to evaluate sine of 7 pi over 12. Does anybody have you probably should have your unit circle close to you too. Okay, so make sure you get a unit circle. Mine's written all over, but so we're looking for sine of 7 pi over 12. So obviously that's not an exact value that we can just pull. Everybody understand that? So what we're going to do is we're going to look for two angles that would add up to 7 pi over 12. Or subtract 7 pi over 12. So you need to find two angles that add or subtract All right. Oh, look at this. I've already kind of done some stuff. I'm going to slide this over here for a second. It would be helpful, and we did this for other things, and I think it was for increments on the axis when we were graphing them. But I know that I'm looking for something with a denominator of 12. So I've changed pi over 6 to 2 pi over 12. Pi over 4 changes to 3 pi over 12. This might help you see it a little bit better or faster. Can you guys see out of those three, two that would add up to 7 pi over 12? Okay. Are there other solutions? Absolutely. Okay. So that's the thing with this unit is that there are so many different possibilities that sometimes the answers will look or the methods will be different, but that's okay. That's what I love about this one. Okay, so what we're saying is that if we add these two together, we're going to get 7 pi over 12, right? Okay, good adding. So we're going to go back here. What am I looking for? Am I looking for cos or sine? Or I guess tan would be an option too, but I'm looking for sine. So, and we said we were adding the two values together. So we're going to go up and use the sum formula because we're adding those two together. So I'm looking for sum and I'm picking the sine because the question has sine in it. Trying to find a pen. All right, so you guys told me that we were going to add together pi over 3 plus pi over 4. That's what you told me, right? You told me that? All right. So we can't just go ahead and smash those together and say, okay, I evaluate sine of pi over 3 plus sine of pi over 4. Like, it's not a multiply through thing. You actually have to use the formula. So we're going to call this alpha and that beta. Those are just two Greek letters that represent angles. Because we can't call them theta and theta because they're two different places. You could call it theta and alpha. You could call it theta and x if you wanted to. I'm just using alpha and beta because that's what's used in our formula. Exactly. It's just saying this is an angle and this is an angle, but they're different angles. So that's why they have to be two different letters. You could use AB, XY, whatever floats your boat. It's just I'm going to mimic what's in that formula. So we're going to say sine of alpha. So the alpha angle is pi over 3. And then we are going to do cosine of beta. Look at the formula. Plus sine, I'm going to do sine of pi over 4. And then I'm going to do cos of pi over 3. You don't have to graph anything in this unit. Oh. So I guess you could throw in some brackets if you want to. I would say that this is one that students struggle with because you lose all memory of chapter 4. And I don't know why it goes out the window, but it does. And so pi over 3 is an angle. You have to evaluate sine of pi over 3. So when we go back to our coordinate pair, pi over 3, sine is the y value. So when you evaluate this, sine of pi over 3 gets replaced with root 3 over 2. Yes. You're not going to have a calculator. Okay? So exact values. You will get a blank one. You'll get a blank one. Yeah. And then if we go to cos of pi over 4, so cos is going to be the x value. So that's going to be root 2 over 2. And then sine of pi over 4, root 2 over 2. And cos of pi over 3, well, I know if sine of pi over 3 is root 3 over 2, then cosine has to be 1 over 2. All right, so now let's see how well you remember grade 10. What? Nothing. Nothing. Okay, so this goes back to grade 10. When multiplying radicals, you multiply the radicands if the indexes are the same, and they're both square roots, so we can multiply them. So that's going to be root 6 over 4. Because when we multiply fractions, straight across the top, straight across the bottom. You guys have all these tools, but I think sometimes when we put it in an ugly format or something you're not familiar with, you kind of lose it, right? Can't do it. But the good thing about it is we have no cubed roots on the unit circle, right? So, but yeah, you could not multiply them if they were different indexes. Okay, so let's go here. Coefficient times by root 2. That coefficient just moves out in front. So that would be plus 1 root 2 over 4. Did I need to write the 1? I didn't, but I thought maybe we should just know where it goes. And they have common denominators, so I can go ahead and add them, but they are not like radicals. They don't have the same radicand, So they have to stay separate. Okay, that was grade 10. That was a lot of grade 12 and a little bit of grade 10. Okay, how does that feel? Yeah, and that's it, like that chapter 4 unit circle. Of course, yeah. You are not expected to memorize all these. Okay, find the exact value of cos of 195. So I'm going to challenge you guys to do this as a subtraction one. So all you're going to do, I'm challenging you to do it as a subtraction one. So you're going to find two angles. So now you're working in degrees. Does that affect anything on the unit circle if you work in degrees? No, nothing. Yeah. Yeah. What are you going to use them for? Good. I'm so glad. Okay, did you guys find two that subtract to 95? 195. What are they? What do we got? I want you to subtract. What? 240 and 45? So does subtraction matter? Does order matter in subtraction? I guess subtraction does matter. So it really does matter. So you need to pay close attention to where you're putting them. So am I evaluating for cos or sine this time? Cos. So now that we flipped the page, this is why I wanted you to keep your formula sheet close to you. Formula sheet close to you. And I'm going to label this again. This one's alpha, this one's beta. And we are going to use a difference formula, but we're going to use the cosine one. So cos cos plus sine sine. So this is going to be cos of 240 times cos of 45 plus sine of 240 and sine of 45. Look at the formula. Look at the difference formula here, folks. This is the one that we're doing. Okay, what's different? What do you mean it's different on the sheet? Okay. Okay. What's different? No? Okay. Okay, guys. Okay. I need y'all to slow down for a second. I need you to think logically about it, okay? Okay, I need you to listen though, because it's really easy to get confused and I totally understand. This dictates if you're adding or subtracting the angles. So notice how these ones are all add, right? So now we just did a subtraction one where we took 240 and we're subtracting 45 from it. So we have to come down to these formulas here because we're subtracting the angles.
So we did a sum one for the sine one?
We did a sum one for the sine one. Because what did we do? We added those two angles together. So go to your formula sheet. What are you doing to these angles? What are you doing here? Subtracting. So this is your differences. Are you adding? Okay. I hope that doesn't trip you up too much. But if you're subtracting, use the formulas with the subtract on the left-hand side. If you're adding angles, use the formulas that have the adding of the angles on the left-hand side, okay? All right. So Terth, does that make more sense?
I was looking at the wrong thing.
Oh, okay. All right. So I spent a little time for no apparent reason. Awesome. Okay. No, that's okay. No, I'd rather explain it than not. Unit circle now. So now we have to. What are you telling me to F off for? That's not very nice. Jeez Louise. So here, this is where we're going to pop to the unit circle. And we're looking for angle 240, which is right there. And we're looking at the cos. So negative 1/2, you need the negative there because that's what it evaluates to. And cos of 45? Root 2 over 2. And it will be a positive one because it's in quadrant 1.
So even though we're subtracting it on the left-hand side, would it still be a positive root 2 over 2?
Well, cos of 45 is positive. You're just evaluating cos of 45. So if we look on our unit circle and go to 45 degrees, cos is root 2 over 2. All right, moving on. So we're going to put an add sign, and then sine of 240 is going to be negative root 3 over 2, and sine of 45 is a positive root 2 over 2. So I don't want it to see anybody have an add butted up against a negative. That's just bad grammar in math. So either put brackets around it or change it to a subtraction sign. I would recommend changing it to a subtract, but as long as you have brackets around it, I can get over that. All right.
Wait, so we can only add things under the root sign if they have the same denominator?
Pardon? Sorry?
Like, we can only add things under a root sign if they have the same denominator? Like,
No.
then why did we add them?
Well, we didn't add these two things together. We didn't times it. We put them as the numerator over 4. Yes. So they have a common denominator, Danica. Okay, I'm not sure what the question was, and obviously I didn't answer it well, but okay, so you guys are going to do this. I'm going to pause the screen, and you guys are going to do this. And you can do add or you can do subtract, but I'll tell you add's impossible. No, that's a statement. I mean, you can try, but I don't know what two values would add to give you pi over 2.
Can they be the same?
Or pi over 12, sorry.
Can you? Oh.
Did you guys find your two angles?
Are you allowed to pick two of the same angles? Or do they have to be different?
Well, they have to be different because two of the same angles subtracted is going to give you 0. Okay, what trig formula are you solving for?
difference of
Difference
sign.
of sign, okay? So that's the trig formula you should be working with right now. And are you? Beautiful.
Yeah, okay. I was doing photos. Oh, God. Okay.
Are you guys good to see it or? Okay. All right, so I'm assuming everybody went back to the first example that we did. Now, there's other options. You could totally use other options, but we will get the exact same answer. So if you pick different angles, no big deal. But we will end up being at the exact same answer.
Oh, yeah.
So these don't matter. This is gonna matter, because you can totally get there using different set of angles. Nope, this one was -2 and -6. But the numbers are really similar. That's a really good point. And then on first page, they were added. They were both positive. So as you can see, those numbers keep kind of popping up here, and you would expect that because really, what do we have for values on the unit circle? We've got like a handful of them, √2/2, √3/2, 1/2, 1, and 0. Like with those combinations, we're not going to get a ton of different numbers. So you're going to see these numbers a lot, but things I'm going to be giving you marks for is, did you evaluate them correctly? These matter. Just because you pick random numbers and you get to the correct answer, if you didn't evaluate these correctly, then you're not going to get that mark. Okay, that's your sum and difference. You might enjoy sum and difference a little bit better than sum and difference in double angles, better than lesson 1, because this you're just substituting values in from the unit circle. So it's almost like those verified questions. So you're actually getting an answer. Okay, double angle identities. Another situation here is where I'm going to give you an angle that, if divided by 2, could be an exact value on the unit circle. All right? So here's the thing. Sine's really nice. It has one option. Tan is really nice. It has one option. Cosine, you can do this one, or this one. So just the double angle is it's right here. That's the double angle. So you're taking 2 and you're timesing it by a basic angle. So you're doubling the angle, hence the name double angle identities, okay? So this angle, notice that this is theta. This also has to be theta. So these are all the same angle measurement. Like in this one, we had alpha and beta. So they had to be 2 different ones. This one will be the same throughout. Everybody with me? So that's the difference here. Okay. Here we go. Now, is 120 on the unit circle?
Yes.
Okay. So we know the answer to this already. What is the answer?
240.
No. What is cos of 120? -1/2, is that what you're telling me?
Yeah.
Are you positive?
No.
So you know that this is equal to negative 1/2. So we're going to use our double angle identities to see if we can get that same answer. So the nice thing is we have the answer for this one and we're just working towards it. Okay. So can 120 be divided by 2? What do you get? Okay, so that's theta. So theta in our double angle identity is going to be 60 because when we multiply it by 2, what's it going to be? 120, and that's the angle that we want. Everybody understand how this works? Okay, what are we evaluating? Cosine. So we have 3 options here, ladies and gentlemen. Which one would you like? Why do you want the second one? It doesn't have sine in it. Sine? So just sine, just cosine, or both? It doesn't matter. This one's nice and easy to do, but we will get into a more strategic. So let's do one with just 1 in it. Basil, you were bold enough to say just cos, so let's roll with that.
Cos of 60 is 1/2, so it's
Nice. Okay, I like it. I like where your head's at. Please note that if you used any of the formulas, we will all get the exact same answer.
So is theta gonna meet alpha then?
Yes. Yep. So this whole thing right here, ladies and gentlemen, is my angle. What's 2 times 60? 120. And that's the angle that we want. And so we're going to put it in 2 cos squared 60 minus 1. All right. I'm not touching anything on the left-hand side. It's just going to stay like that. So so really, ladies and gentlemen, mathematically speaking, that's what we're about to do. So you have to evaluate cos of 60 degrees. Basil, what did you say it was? 1/2. So now we have to square that 1/2. I'm now out of room, so I'm going to move off to the other side. So I'm going to have 2/4 minus 1, 1/2 minus 1, negative 1/2. Does it match the answer we know is correct?
Yes.
Look at us, smart people. Okay, that one was more like a, please trust me, this math works example. So now I'm going to show you how you're going to use it for realsies. And this is a question that comes up an awful lot on the final exam. And probably your test. Hint, hint, nudge, nudge. Okay? Do what you will with that piece of information. So I've given a little bit of information here. I've given that cos of pi over 20 is equal to 0.99. Okay? I've given you that information. You don't have a calculator, so you have to trust me. Okay? You have to trust me on this one. And then I ask you to evaluate what cos of pi over 10 is. So we can go ahead and use a double angle identity here, because if I take 2 and I multiply it by pi over 20, what do I get? Pi over 10. So if I apply a double angle identity to this information that I have, I'm going to get the angle that I want. Does that make sense to everybody? Okay, so but I only have one piece of information. I only know what cos is. So that forces my hand in what cos double formula I use, double angle formula I use. Yes, I have to use the third one. How come, Nicole? Was that you who said that? Who said it? Cam? Danica? Okay, why do I have to use the third one? I only have cos. I have no information about sine, so the only double formula I can use there is cos. So cos of 2 pi over 20 is equal to 2 times cos of pi over 20. Ooh, forgot my squared, sorry, minus 1. All right, here we go.
What? Did we just do cos? What?
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 Why isn't pi over 20 2 times?
Why is
What?
pi over 10 on the right side?
The right-hand side?
Or, no, should it be, what?
No, I've got this
Oh,
solid.
yeah,
I'm
yeah.
good.
Yeah, you're good. Never
I'm
mind.
good.
Sorry.
That's okay. I'm good. Do you guys know why I'm good?
Can you write?
What does this equal?
Yeah.
Pi over 10 happens on the left-hand side.
Can you just write cos pi over 10?
Does that make you feel better to do that?
Yeah.
Okay. But this is important because if we go back to the formula, this theta or this alpha has to be the same throughout your formula. So that's why I hesitate to put this in. That's why I don't do that. I don't write that step because I know that this angle has to be the same as this angle. But that's how I've trained myself to do it. Because I know that these have to be the same in a double angle identity. But you guys are going to do what's best for you. This is not wrong. This is 100% correct. But then, do I know that this is pi over 20 goes in here, not pi over 10?
But why?
Well, you
But why what?
Why isn't it pi over 10?
Do we have any information about pi over 10? I got nothing. What do I know? I know cos of pi over 20 has a value of 0.99.
See, the way I'm doing it, it's just the number that we're evaluating is always on the left-hand side.
Okay, and that's fine. And it's like as long as you know that that's not the number that gets substituted into the formula. You need that double angle there. I need this because that's the piece of information that I have. Okay, so what does this evaluate to?
0.99.
This is what was given in the question.
How do you compare that?
Okay, we're gonna have to use our calculators. I wouldn't do this to you without a calculator, unless it's a nice number.
Samar can do it with that calculator, so let me do it. Just like one, yeah.
I love it. Everybody's like, and now it's just basic stuff, right? So we know that cos of the double angle, and I know Basil, you will write it differently, and that's okay. That's 100% okay. Like if you want to write it as cos is pi over 10. I just get into the habit of only using my halfer angle all the way through so that I don't get confused as I go. But that's a strategy that I use to keep myself organized. This one was another good one taken off an old provincial exam. Yeah.
Yeah.
So, hint, hint, nudge, nudge about that question. This one showed up as a multiple choice question on a provincial exam. Okay, looking at this. Can you identify what summer difference identity this is?
Some of the signs, I don't know what that is.
Well, we can't evaluate it if we don't have a calculator, right?
Sine alpha plus beta.
What is it, sorry?
Sine alpha plus beta.
Sine alpha plus beta. So, sine alpha plus beta has, so it's sine alpha minus beta.
Yeah.
Because look at, so you guys would say that this is alpha. That's beta. That's beta. That's alpha. Right? You guys would agree with me? So you're looking for an identity that has alpha, beta, sine, cos, like so they're different, and they're subtracted. So if I go through this list, it just happens to be the first one. Sine, alpha, beta, sine and cos are in the first one, alpha, beta are in the first one, same thing in the second one, and they're subtracted, right? So we would all agree that it's this one here? Okay, good. What do we know alpha is? 48. What do we know beta is? Brilliant. Okay, I want you to go ahead and subtract those. Pretty basic. Don't pick up your calculator. Somebody tell me what this is. Say it out loud. 31. So you've now written it as a single trigonometric function.
So that's it for this?
That's all for that question. Like I said, this showed up as a multiple choice. I'm not saying it's going to show up as a multiple choice again. Okay. Do that one. Okay, first of all, find the identity. I will tell you that it's not a sum or difference. Yeah, okay. Yeah. Yeah, cos 2 alpha, cos. So this is a double angle. How did I know that? I looked at the formula sheet, but another thing is, do I have two different angles here?
No.
So right away, I know I'm in the double angles. Because the sum and difference have two different angles in them. The double angles only have one. So that's how I know I'm in there. And this is cos 2 theta. Would you guys agree with that? Yes? Okay, so now we're going to solve it. What's my angle? Pi over 12. So that angle changes to pi over 6. What's cos of pi over 6? Pardon? Root 3 over 2. Okay, good job, everybody. All right, I'm going to flip for a sec. We're going to do this one. Okay, this one will be on your quiz, will be on your test, and will probably show up on the exam. This is a triple hitter. I know I skipped one. I'm going to do this because Amber's got to go early. So I'm going to do this one first and then I'll go back. So this one is a triple hitter. This one is going to be in multiple places. So you want to play close attention. All right. Cos alpha. What does that restriction tell me? Has to be in quadrant 2. Okay, because we know cosine's negative in quadrant 2 and 3. This specifies that it's in quadrant 2. So now I need you to draw me a picture. You guys are good at this. You've done this a million times. You've done this in chapter 4. Draw me the picture that goes with this. Where am I going to be? Quadrant 2. I'm going to label that as alpha. My 5 is going to go here. My negative 4 is going to go here. I'm going to tell you, ladies and gentlemen, you need to find the other side. I don't know what's happening over there.
So is the hypotenuse always c squared?
Yep. I'm going to ruin your fun. Is it a positive 3 or is it a negative 3? It's positive, right? Because you're in quadrant 2, so it should be positive. So we know from the question, it gave me that cos alpha, oh, that is an infinity sign, not an alpha. Cos alpha is equal to negative 4 over 5. What is sine alpha? Why did I have to do sine and cos? Okay, yeah, it is a formula. I'm just going to slide this down for 2 seconds. What am I looking for here? I'm doing a difference, a cos difference formula, and I need information about sine as well in that. Do I need information about tan in that formula? No, so I'm not going to do that. Okay, so that was drawing number 1. That's drawing number 1. Drawing number 2 occurs from this piece of information. Please note that that is cos alpha. What's this one? Beta. So you're going to have to draw me a new picture for this one. Okay, so what quadrant am I in?
3.
So I am in quad 3. And now that angle's beta there. This will be 13. This will be negative 12. That side will be 5. Yeah, sure. I feel like the screen pen is not showing up very well. That's a little bit better. You're right. It would be of -5. Thank you. Good catch. All right, so we know from the question, cos of beta is equal to negative 12 over 13. What other piece of information do I need? I need sine of beta. And sine of beta is going to be negative 5 over 13. I need to have both sets of information before I do that, before I can answer this question. So step 1, draw the picture for the first alpha, and step 2, draw the second picture for beta. And this is where the wheels fall off the bus. But it's okay. We're smart people. We can put them back on. All right, so we need cos of alpha minus beta. Is it important that we know what the angles are? No. Nope. Because all we need to know is the values of them, right? So the formula for cos alpha minus beta is cos alpha times cos beta plus sine alpha plus sine beta. I just grabbed that off my formula sheet. I do not know the angles. I do not need to know the angles. Because I know what cos alpha evaluates to. What does it evaluate to? Negative 4 over 5. Negative 4 over 5 is not the angle. It is what cos of the angle is. So that's going to get replaced with negative 4 over 5. So it's not really important to know the angle in this particular question because I know what cos of alpha is. What's cos beta? Sine alpha, 3 over 5, sine beta, 13. Whew, okay, I got the numerators. 48. What's 5 times 13? 65, good job. And then negative 15, also over 65. So my answer is going to be 33 over 65. Hint, hint, nudge, nudge. quiz, test, exam. If you can simplify, you want to. Can I simplify this one? This one I can't? I can? 3 goes into 65? Because I only have 3 and 11 there, right? Okay. Okay. All right. Do you think you can do the next example on your own? Okay, go. Let me draw you some colors. And ladies and gentlemen, if you don't want to draw the triangle, like if you don't want to draw it on the coordinate plane and you know it, that's okay too. But I think it's helpful to draw it on the coordinate plane.
40 and 41, what is this?
Is negative three gonna be like opposite on the triangle?
What? Sorry?
Like for sine alpha, when you draw it, is it gonna be negative three on the?
Well, what quadrant are we in? So when I draw this, alpha's here. Where's the opposite side to alpha?
I'm just asking.
Yes, Anita.
Thank you, God.
Dynamic calculator.
It's a Pythagorean triple, I'm pretty sure.
Wow. Yes, ma'am.
Why is it a positive four? Oh, wait. Why is it a? No. Oh. Oh, never mind.
What is 5 times 41? 805?
Pardon?
Is 5, what is 5 times 41?
What's 5 times 40?
Oh, 200, yeah, I was gonna say 800, never mind.
Yeah. And then what's 5 times, yeah, 205.
Okay. Okay, you're gonna say 11.
Am I allowed to show you the answer?
No.
Okay. Am I good? Can I show now? Who keeps telling me no? What? Because it's sine. Why are you yelling at me? We have one thing to do. She's okay. Does everybody get what I did there? Is everybody good with that? Okay, you know, if it's not working out, then come see me and we'll figure it out. Let's go back to this example. Okay, you know what, guys? I think I'm going to leave this example for tomorrow. Just so we can call her done for today. It fits in really nicely with tomorrow's lesson, doing mathematical proofs. And you guys, okay, you have a quiz on Wednesday, and it's on Friday's lesson and today's lesson. So you need to get your life figured out by Wednesday.